Mechanical engineering students are often required to draw the yield surface of ductile materials in two dimensions. However, for the beginners, it can be a little bit confusing. So in order to ease that, I will be giving you a series of steps to be followed in order to draw the yield surface. Before I describe to you how to draw the yield surface in 2D, let us briefly discuss what is that yield surface. Yield surface is the surface connecting a set of points describing the limiting states of principal stresses beyond which the yielding takes place. To tell you in simple words, as long as the principal stress state is within the inside the yield surface, no yielding is going to take place. When it goes outside the yield surface, then the yielding takes place. In the majority of mechanical engineering structural applications, yielding is counted as failure. So if we want the structure not to yield, then we have to keep the stress state within the yield surface. Now I'll describe to you the first step. So since the yield surface is described in terms of the variables sigma 1, sigma 2 and sigma 3, which is the first, second and the third principal stresses. So the first step to draw the principal stress in 2D will be to draw the coordinate axis, sigma each showing sigma 1 and sigma 2. Sigma 1 is shown in the horizontal axis, sigma 2 is shown in the vertical axis. Please note that here, since we are describing it in 2D, there are only two principal stresses, sigma 1 and sigma 2. If we do it in 3D, there will be three principal stresses. The next step will be drawing a vertical line uh, corresponding to the sigma yield point, that is the yield point stress on the sigma 1 axis vertically. Next, what we do is that in the positive sigma 2 direction, we draw a horizontal line representing the sigma yield point in the sigma 2 axis. So these two lines meet at a point. The next step will be that whatever we have done on the positive side of sigma 1 and sigma 2, the same thing we do on the negative side of sigma 1 and sigma 2. Again, two lines meeting at a point. Now, the next step will be to form a closed figure by connecting the open ends by straight lines. So there is a straight line connecting positive of sigma 2 to negative of sigma 1, and there is another straight line connecting the positive of sigma 1 to negative of sigma 2. So the closed figure that we have got on the screen now, that is also a yield surface, but it is the yield surface according to the Tresca criterion. That is not the most popular uh, criterion used in the industry. So the next step will be to draw the yield surface according to the von Mises criterion, which is the most popular criterion used in the engineering industry for predicting yielding of ductile materials. Now we come to the last step, that is drawing the yield surface according to the von Mises criterion. So in this step, uh, we have to simply connect all the corners of the Tresca yield surface by an ellipse. So as shown on the figure, you can see the red ellipse, right? And that red ellipse represents the yield surface according to the von Mises criterion. I have so far described how to draw the yield surface. Now I'll be making some observations. So the Tresca yield surface is fully inside the von Mises yield surface. So the Tresca yield surface is more conservative. Secondly, at the corners, that is where when the stress state is unidirectional, the Tresca and von Mises criteria give the same yield surface, so the same yield value also. Secondly, so but at many of these locations, you can see there is a difference between von Mises criterion between the yield surface according to the von Mises criterion and the yield surface according to the Tresca criterion. So this difference can go up to 16%. If you like this video and want to view similar content, do like and subscribe to my YouTube channel. Thank you.